Lesson 10.2, probability. On the skills standards, you can see vocab, we're talking probability, as well as over here, the skills, recognizing probabilities between 0 and 1. I'm also going to talk about this interpreting and also work on this last one too. So today's really big on our standard. When we talk about vocabulary, probability is the number that measures the likelihood that an event will occur. Now we're going to talk about this number as a fraction, decimal, or a percent. But when we talk about probability, when we describe it, we use these words down here. And as you can see, we're going to look at the word impossible, unlikely. I want to say just equally likely, likely, and certainty. Now, when we look at those, there's a few different ways. You can see we've got 3 different columns here. So we're looking at fractions, decimals, and percent. It has to be exactly 0 to be impossible, and it has to be exactly 1 to be certain. After that, we're looking at which is it closest to. Is it closer to unlikely, closer to 25%, closer to 50%? Is it closer to 75? Again, to be impossible, it has to be exactly 0, not closer, exactly 0. And to be certainty, it has to be exactly 100. So 99% is not certainty, it's very likely, just likely. So we look at that. We talk about weather forecast, maybe a good, maybe a bad example, but there's a 20% chance of rain tomorrow. When it says describe the likelihood, we go back to this previous screen and we take a look. It is not 0 and it is not 100. So those are not our options. So when we look at 20%, we're trying to figure out which one of these 3 on the bottom, because it's percents. Again, ignore the little black dots from previous slide talk. Which one is it closest to? So since it's closest to 25, we're going to take the word unlikely. When we talk about the likelihood of rain tomorrow, this is not a real forecast. It might overlap every once in a while that it is, but this is just an example. The likelihood is unlikely. To find the probability of an event, we take the number of favorable outcomes, again, what we want, over the total possible ways. That's it. It's a fraction, and because it's a fraction, we're going to have to make it in simplest form. So here again, you can see we already covered this interpreting unlikely, equally likely, and likely events. We're talking about probability between 0 and 1, and now we're going to work on this, a skill, so that we can be right up here where we want to be, a level 3, where you can say, I know, and it can explain the probability of an event, and then, of course, explain it as occurring the likelihood of it happening. So let's talk about, again, number cube. We talked about it yesterday. When we talk about a number cube, it is a singular die with the numbers 1, 2, 3, 4, 5, and 6 on it. When we talk about this first question, it says, what's the probability of rolling a number greater than 4? You are welcome to write these numbers down each time if you need to. When we look at that, what's the probability of rolling a number greater than 4? Our favorable outcomes. How many of them are greater than 4? There are 2 out of a total of 6. 2 out of 6 total possibilities, which again, because it's a fraction, needs to be simplified down to 1/3. If you would like to, again, down here, write out the possible outcomes, you can do that. We talk about the possible rolling an odd. You can do again. 1, 2, 3, 4, 5, 6. List all the possible outcomes. And then from there, you can look at which ones are odds. Again, our favorable outcomes, a 1, a 3, and a 5, giving us 3 out of 6. So the probability of 3 out of 6, which will simplify down to 1/2. Please always make sure your fractions are in simplest form. When we talk about this, they're going to use shorthand here to see on the next example. So sometimes instead of writing out this huge phrase here, instead of saying what's the probability of rolling a 7, they're going to use a big letter P and then put what we want, our favorable outcome here on the inside. So what's the probability of rolling a 7? Again, if you need to list them all out, here's the possible outcomes, 1, 2, 3, 4, 5, and 6. Our favorable outcomes, how many ways can we get a 7? Well, there can't. There are 0 ways out of 6. So the probability of that is 0. That's where, again, we can say the likelihood, describing it, of rolling a 7 on a normal number cube is impossible because there are no other numbers that make 7. Now here again, be very careful when we look at this word. What's the probability of not rolling a 1? How many numbers are not 1? 5 out of the 6 are not 1. If you need to go back and you need to list out all the possible outcomes every time, do that and look at how many of them are not 1. Not 1. Count them up, the favorite outcomes, again, 5, and that's just how we write it as a fraction. Here it is. It doesn't write out the whole phrase, but this is what we're looking for. This inside the parentheses is our favorable outcomes. It's saying, what is the probability of getting a prime number? Please remember, this is something that we have to know. Prime numbers are 2, 3, 5, 7. They are anything that have only two factors, the number 1 and itself. So only things that multiply to 3 are 1 and 3. The only things that multiply to 5, 1 times 5. There are no other numbers. So we look at this list, which of course goes on and on and on. But these, looking at our spinner, we've got the number 2, the number 3, and the number 5. 3 favorable outcomes. 3 that are prime out of 1, 2, 3, 4, 5, 6 of them. Please remember to always simplify that down. 1/2. Multiples of 3. Here come math terms. Now multiples. 3, 6, 9, 12, so on and so forth. How many of those numbers are on our spinner? When we look at that, I see a 3 here and a 6 over here. So that's where we get our favorable outcomes. There are 2 of them out of 6, which simplifies down to 1/3. And cleaning all this up, now we have this other math term of factors. Factors are numbers that multiply to 6. So factors of 6 are 1 and 6, 2 and 3. Of those factors, which one of these factors are on our spinner? The number 1 is, the number 2 is, the number 3 is, and the number 6 is. So the favorable outcomes, 4 out of 6. Again, simplify it down to 2/3. Now, in this instance, all of the factors were on our spinner. That's not always how it's going to be, but in this example, it did. You just find the favorable outcomes. How many of these factors were on the spinner? And that's what you put here on the top. Now, there are a couple different ways to solve this problem. I'm going to show you the way that always works. You might be looking at this already and say, I already know the answer, which is great. Probability draw a short straw from a group of 50 straws is 9 out of 25, so it asks how many short straws are there. Again, you might know it already. Let me show you one way that will always work. When we take this probability, 9 out of 25 is the probability, and we're going to take this other number, since it's a total of 50 straws, and we're trying to figure out how many of them, put a variable up there, how many of them are short straws, we can go and solve this. Now, some of you right away say, Mr. Walls, I know the answer already. Well, you're right. You can see that one way to solve this is using the cross products, where you take 9 times 45, and then the other cross product, where we take x and the 25. So we'll take 25x, solve that by dividing by 25, and that's where we get x equals 18. So there are 18 short straws. That method, the cross product, always works. Now, if you saw it right away, I will allow that, but make sure you show me the work. If you say, well, Mr. Walls, 25 times 2 gives us this 50 over here, so 9 times 2 gives us 18. Bingo. Just show me this work right here, and that's good enough work to find our answer of 18 short straws. Again, we did this because now we're talking about probability. We talked right away about describing the likelihood of event, and now we're working on this here, writing it as a ratio a fraction, which we could also switch over to percent or decimal. All acceptable. I usually just write them as a ratio. So again, today our goal is to understand the concept of probability, the relationship between probability and likelihood, and then the big one that we'll always see, especially on standardized tests, find the probability of events.